Today we're going to talk about some new research that we conducted a few months ago. So in this research, we're going to talk about extensions, hybrid cloud, and the risk in that. And we're going to reveal how we impersonated Google Cloud Code and actually stole some real accounts over the wire. So how do we start our research? So when I used to be in the military and the intelligence corp, we knew that people love DevOps tools and love the integration, but they never put attention to what risks come with these features. They never know what permissions they're giving those tools. They never give any attentions for the implementation and for the permissions they are giving. So when I joined Upwind, I saw some major organization, over $10 billion value organizations that use DevOps tools, but restrict some other issues. Like they do remember to block their S3 buckets, but they do not know that their DevOps with the root account permissions logging from a dirty laptop with Pornhub on. So you need to know what you're fighting for, and you need to understand that your personal laptop is like a weapon and your cloud environment should be sterilized. And this is how we conduct this research. So before we even start talking about security and issue with security, my core belief is that security personnel need to understand technology prior to the security stuff. So let's start understand the issues and problems with, maybe we'll give a few minutes for people to go in and we'll continue because is there a lot of people?
Yeah.
Okay. Okay. I'm from Israel. In Israel, the audience is also problematic, but yeah, I'm still figuring my way out here. So, yeah. So first of all, and I also like to move. So if you don't hear me on the back, just raise a hand and I'll change my position again. So first of all, we have the developer. He wants to develop fast. The DevOps guy, he wants to develop fast. He wants to move fast. He wants to work from his station. So he go and gets himself an IDE on his laptop. And then the IDE has a marketplace because you want to move fast. You want to install packages. You want extensions. You want to work fast, integrate everything. And you actually go to the marketplace and install Cloud Code. But what does this extension do? So it simply connects you to everything. So as you can see, Cloud Code actually allows you to get full access to your GKE and every Kubernetes cluster that you manage through GCP, your GCP account with fully permissions, and some Docker environments. So we thought to ourselves, why does this so powerful tool is even a public extension in the marketplace? It's supposed to be something that you actually get directly from Google or directly from your cloud provider. And then we examined the authentication method. And then we saw that the authentication is going through the VS Code itself. And then we had some questions. Why do I need to authenticate from my IDE to my provider? So why do I need my IDE to know my creds directly and not use some plugin or extension and other extension of my provider? So many concerns started, and that's when we decided that we want to attack this specific tool. This is me and my team thinking. I see myself as Patrick and my fellows as SpongeBob, but we thought really hard. And we came up with the attack vectors that we know from the intelligence corps. And we thought to ourselves, okay, what I'm going to look for when I'm exploiting and searching for vulnerabilities in extension. So the first thing is that developers assume that everything they build is secure. This is an assumption that is basically irrelevant and incorrect, but most of them just leave unsecured APIs and unauthenticated stuff for their own purpose and for good reasons. The next thing that we know that attackers and developers do, they join together. So they also expose internal APIs that shouldn't be exposed for external users. The last thing is the impersonation and supply chain, which is a known common issue in the extension industry. The next thing is an exposed secrets, which is the issues of everything and everyone. And the last, but not least, is the leftovers that developers leave in their source code. So what we did, so we took this extension and we actually reversed it backwards, which is the most common profession in Israel. And we actually understood that the developers left us with a lot of artifacts. We found some source code, we found some secrets, we found some unauthenticated APIs. and many stuff that we could do. And we even found a Firelog API key that actually works for Google directly, which was funny because we start sending them some mocks logs and like, hey, I got here, and hey, I did this and that. And just to give you the sense of what this means, if I get an API key to a Logstash or an Elastic service or something like that, I'm actually gaining access to inject raw data into your organization, which means like your DevOps procedures and your pipelines will actually process my data. If we're talking about in the last 4 years, we saw many vulnerabilities that talks about how you inject code into logs, like Log4j, and we saw it also this week is with the JSON path, and many other vulnerable components. So this is a critical issue, but we didn't focus on that. So what we found was a bit more viable, as I see it. We found the authentication method in plain code. So this was very nice. Just for setting things up, Google VS Code extensions are actually based on JavaScript code, which actually is a plain code, as you probably know. But you can actually minify, pack it, and obfuscate it, which actually could make it harder to understand what is going on there. But as you all know, I came from the army, and I know how to reverse things backwards. And what we found was very nice. So on my left side, upstairs in the corner, you can see that they're actually plain code in CSV files, which are actually very odd. Why do you put your code in CSV file? I'm not sure it's stable, but we tried to open it, and it's still a plain code and not a CSV file. The next thing that we found API documentation that shouldn't be exposed, internal exposure. We also found many zip files with source code that shouldn't be exposed. And eventually, we even found this code. So if we can go, I hope you see this code, but if you can see in the middle, there is actually the authentication method that GCP used to authenticate their edge clients. And they actually left the scopes there and the client secret and the client token, which actually allowed me to develop any application that I want with GCP authentication. And this is how the code looks in the CSV format. It's not rendering. So if you had worries, it's not looking well. So we thought to ourselves, how are we going to weaponize this vulnerability? So we found an issue, we found a misleading in this app, and we want to understand what can we do with that. So we have the attack vectors, we have a problem, now we need to build a weapon. So we start with classifying the tokens that we found, the cipher code that we found, and we understood that we can actually authenticate and get information of every user in the organization through this application, because this application allows users to actually map everybody in the organization and just log into them. But what else this application does, it gives you an admin access to GCP. So we understood what this OS token does, and we start testing it and try to implement it in our weapon. So we start with a mock application in Python with Flag Server, which wouldn't make any of you sign in, I hope so, but you wouldn't log in into this application. So the next thing that we did, we just tried to use it on our DevOps employees in our company, and we saw that when they logged in, we actually got a full access to GCP, and it looks the same authentication process as just a normal GCP application. The next thing that we did, we actually go to ChatGPT like everybody else does this day, and we ask him, hey, Chat, dearly Chat, can you give me a JavaScript extension for VS Code? And 3 minutes later, I was in the marketplace. So, but the only issue that we had, we need to understand how to exfiltrate the token directly from the client into our new environment. So we have a plan, we have a weapon, we have the attack techniques, we have the exploitation. Now let's get to the procedure. So in the code upstairs, you may see the server that we set it up. This is how a VS Code extension, you have the activate function, deactivate function. Those two, every function in a VS Code extension is actually a functional button in the VS Code. So what we needed to do is we actually built a trigger function that every time you install our malicious extension, then it will trigger, hey, please log into GCP to continue working with us. And we actually set a blob storage. Thank you. Oh, so you didn't see anything. Right, okay. So it was good, it was very great. It was the best code you would ever see in your life. I'm sure. But now you don't see me. Just kidding. It's okay. It's better that way. Okay, but I need to see. Okay, now we can work it out. So eventually we start building this application. So we have the activate function, which actually, when you start your VS Code, it pops out and say, please log in. And we also set it up a connection to blob storage in Azure, just for the cross cloud functionality. And then we started to build the entire function. So this is the actual authentication method that we stole from Google Cloud Code. And we actually implemented as is. So this is how it might look for a GCP customer. This is the same icon and logo of GCP Cloud Code. And also, we managed to mock everything out. So when you actually log in, you would see like you are logging into Cloud Code. So any questions so far? Okay. As you can see here, the message says like, hey, you're going to log into Cloud Code. And this application name is quite different, as you can see. So we named our application Malicious Cloud Code, like everybody could see it, but they still download it. But when you install it and you go into login, you still see Cloud Code. And if you press on the Cloud Code button, you would see GCP emails for support. You won't see my email. And this is how we made it work. So if we sum things up, so we started with a client. We understand that the client is vulnerable for an impersonation attack. And then we start and connect things up. So we start on the left side bottom with the client. We add the functionality of exfiltrating the token. And we ask our customer, hey, dear customer, please log in into our platform. So when the customer actually logs into our platform, he goes to GCP, generate a token for himself, and actually give the token back to us. So we had the main issue with this kind of applications and this kind of attack, that you have to make your client believe that you are the malicious application. And the other thing that Google does, I'm not sure if it's good or bad, but they implement their authentication with a local server, which means that when you actually install extensions, you're actually installing a local server that authenticates you locally. So this is how it looks after we created the mockup. So we stole some, the token is hidden here, and we also have the account that we stole it, and we won it. But we need to understand that when you're developing an extension and when you're installing an extension, most of the time you're installing random code and outsourced code that you don't know and don't scan. I believe that we saw earlier a presentation about Terraform by Zest. And they also got into the same conclusion from different perspectives, the perspective of the IAC. But I'm talking about what about our personal computers, our hybrid cloud approach. So as I see it as a security guy in the industry for the last 10 years and 8 years at the DoD and the Cyber Command in Israel, I believe that hybrid cloud is one of the main issues that we're going to see in the industry in the next 5 years. And I believe that we need to understand that all of those DevOps tools, all of those integrations are putting us at risk, and we need to handle it better. So how do we suggest to solve this problem? So the first thing that we suggest, like every other CISO and every other, I think I heard this first quote like 10 years ago, but just refresh your creds. So, okay, just refresh your creds every few hours, every few days. I might leak your creds once, I might leak your creds twice, but sometimes you'll figure out that your creds been stolen, and you prefer your attacker to have limited access and not like a sustainable connection all the time. The next thing is that if you have a sensitive extension like Cloud Managers, please put the authentication on the server side. You can always make the application authenticate remotely and not locally, which actually can solve many problems that we saw in this extension. Another thing is that we suggest is to change the architecture of most of the extensions. In this case, we saw that Google developers didn't remove any of their source code, any of their to-do list, and anything. This is not a beta product, this is actually a GA. And we still see a bad behavior of developers. Next thing is to limit access. So all of the extensions that we examined didn't ask for us for a limited access. I know that this is the responsibility of the IDP, but when your plugin is actually designed to be a root access admin, then it's very hard to limit it afterwards you're already engaged. And if we are talking about startups and small companies, it's a major issue because all of the eggs are in the one bucket. Avoid hard coding sensitive information. So this is something we see in many extensions. We also saw it in Argo CD exploitation that we posted a few months ago, and also in Flux CD. So this is a major problem in open source community. They document everything, and everything is clear. And attacker can actually exploit it in like several minutes. Next thing that we think that you should do as a security engineers is to limit your API access. Limit and also separate it from one location to the other, and also separate between dev, beta, and dogfooding to the GA API. Next thing that we suggest is to track and log the unusual activity of the token. So in my case, what I did is like we installed a malicious application in customers' computers, and we took their token and uploaded it to the cloud. So the next login that the attacker will do will be from another console, like a CLI tool or anything else. And as you probably understand, every parameter of the authentication will be different. The geolocation, the user agent, and every basic login parameter. So if we could take the correlation between a DevOps tool and integration, something that I know that I'm using, and the method of the authentication, I could actually correlate them together and get a quality detection that says, hey, these credits are for Google Cloud, or these credits are for CLI tool, and they are being logged in from Python application, or from Uzbekistan, while your DevOps tool is in Germany. So this is how we recommend to handle this stuff if you're building an extension or using one. And last but not least, when we're talking about runtime and what we do in Upwind, so we actually provide our customers the ability to aggregate all those three stuff. So we correlate between the geolocation, the time, and the client, because we believe that security happens at runtime. We saw many incidents in the industry, but none of them was solved because of a shift left product. Not that it's not important, just because we need to engage with the runtime, with the production. We need to understand that attackers do not live in our planning. Most of the supply chain attack does, but let's say that if somebody hacked to my production cluster, I don't care about my source code. I'm being hacked, my money is leakage, I need to report to the stock market, and I need to engage with many stuff. And this is why we took this approach and not going into the left and seek for misconfigurations. The next thing that we highly recommend to most of the organization, this is actually a lesson that I took from my reserve time in the military. Please limit your access to bring your own devices, and also for personal laptops. We see that many attacks start with that. Many companies provide unlimited access to your private computers. Please watch out what you're safe from. Acquire an additional device, and do not use the main device for personal use, the personal device for work issues. And the last thing, which is actually trivial, but none of the organizations that I work with does it, is please limit access to geolocation. Okay, this is quite simple. Most of the companies work from sites and from zones. And I think that none of the US employees should log in from Thailand if they are not on vacation. And if they are on vacation, you have many solutions to solve that and give a limited access. So how we discovered this? How did we discover that somebody is being attacked? So we tried this on our customer. And as you can see on the left, we see the Okta integration of our customer. After that, we have the user itself, their permissions, the cloud accounts. And on the right side, the cloud code is hidden. So when you're using extensions, most of your providers will actually give you the indication that you're using some clients like that. We know that Amazon does it, we know that Google does it, and also Azure. And you can actually monitor and track third-party applications that your organization been using like that, and trace it back. So if you're using Appian, you will get this map immediately, but this is how we take the data and understand it in real time, in runtime. And we can actually limit the access for our customers at the moment. So thank you all. If you have questions or anything, I'm free. And stay connected with us if you want to meet me this weekend at New York on the right, and if you want to meet me at Upwind at the week on the left. So thank you all. Any questions? Thank you. Yes?
Yeah, I don't know if this is outside the scope of the talk a little bit, but maybe it doesn't seem very practical to review all these extensions and code and perform best practices. Has your team come across any ways to verify a Chrome extension and be trusted?
Okay, it's a good question because so the question was, do we review every extension and what do we do with the extensions? What do we do to secure those methods? So I believe that security need to give the engineers the ability to work and not to block them, because if the engineers will know that security personnel are going to help them, then they will solve vulnerabilities, they will solve security issues, they will be engaged in this position because the road is double way, not one way. So I believe the responsibility is for the security side to actually check it in passive mode and not active mode, and not block the developer. It depends on the size of the company. If you are talking about enterprises, then probably it should be forbidden first. But if we're talking about small to large companies that still can manage those extensions, I highly recommend to allow first and then examine. The thing that I would have examined the extension on Sandbox, what I would do is I will install it on a clean environment, let's say, for example, a laptop, install the extension, and see how the identity behaves. So if we're talking about a modern IDP, so everything have logs. So I'll take the extension, run it on Sandbox environment, see what logs it generates, and understand which things it access to. Most of the extensions also have network connectivity locally that can be exploited, but this is something that we cannot predict. So I do think that we need to stay alert. We don't need to allow anything, but we do need to allow. And I think that modeling the extension could help us avoid these things. Next up. Yes.
Did you report the cloud code issues to Google?
Yes, of course. Yeah. I thought I was going to get a free vacation, but I got a mad-face email that says this is not a vulnerability, this is an issue, this is a bug by design, and this is how the authentication is designed. So I told them, okay, if this is how you design, this is how people are going to log in. So yeah, we reported it, yeah. But I didn't get a free vacation. So, okay, thank you guys. See you soon.